हेलो सब्सक्राइबर्स, वेलकम टू लेट नाइट इंजीनियर्स। और आज हम देखेंगे HPC यूनिट 3 पैरेलल कम्युनिकेशन। सो लेट्स स्टार्ट। सो व्हाट पैरेलल कम्युनिकेशन इज? इट इज़ वन ऑफ द concepts in high performance computing in जहाँ पर multiple processors work together to solve a problem quickly. Since many processors are working simultaneously, they need to exchange data with each other, and this exchange of information between processors is called parallel communication. Without parallel communication, क्या क्या problems आ सकती है is processors cannot share intermediate results, tasks cannot be synchronized, और performance decrease हो जाती है. What parallel communication focuses on is how many processors exchange data, how fast communication happens, and how efficiently communication is performed, and how communication overhead can be reduced. So in HPC systems, communication costs often becomes major bottleneck. What this means is ज़्यादा processes and ज़्यादा काम करने की वजह से systems overheat या फिर overrun हो जाते हैं. In order to prevent this, parallel communication is introduced. Even if processors are extremely fast, poor communication can slow the entire system down. एक रियल लाइफ एग्जांपल से देखते हैं. Imagine a group project in classroom. One student collects information. अभी उसी ग्रुप में एक बच्चा information कलेक्ट कर रहा है. The other creates the PPT. तीसरा डॉक्यूमेंटेशन कर रहा है और चौथा प्रेजेंट कर रहा है. All students communicate continuously with each other so as to execute all these tasks. अगर कम्युनिकेशन पुअर हुई, वर्क डुप्लीकेट हो सकता है. सम स्टूडेंट्स रिमेन आइडल, उनको कुछ काम नहीं मिलेगा. फाइनल आउटपुट बिकम्स इनकरेक्ट. सो सिमिलरली HPC systems में processors must communicate efficiently and regularly for successful parallel communication. अब आते हैं टाइप्स ऑफ पैरेलल कम्युनिकेशन में. टाइप्स ऑफ पैरेलल कम्युनिकेशन में मेजर कम्युनिकेशन ऑपरेशंस इंक्लूड वन टू ऑल ब्रॉडकास्ट, ऑल टू वन रिडक्शन, ऑल टू ऑल ब्रॉडकास्ट, scatter operation, gather operation, prefix sum operation, circular shift, blocking communication and non-blocking communication, and communication cost analysis. सारे टॉपिक्स को हम एक एक करके पढ़ेंगे. So let us start with one to all broadcast. What one to all broadcast is? One to all broadcast is basically one processor, also known as source और root, जो सेम मैसेज सारे प्रोसेसर्स को भेजता है. फॉर एग्जांपल, ये तुम्हारा सोर्स या रूट है, रूट प्रोसेसर. प्लीज इग्नोर दी हैंडराइटिंग. जो सारे इंफॉर्मेशंस को दूसरे नोड्स को भेज रहा है. So basically it is used when all processors need identical data. सारे processors को सेम डेटा चाहिए. ए इंफॉर्मेशन. अगर रियल लाइफ एग्जांपल से समझाना हो, then we can take an example where a teacher announces exam instructions to the entire class. जहाँ पर टीचर तुम्हारा रूट है और स्टूडेंट्स तुम्हारे अदर प्रोसेसेस हैं, और इंस्ट्रक्शन तुम्हारा इंफॉर्मेशन है और मैसेज. सो व्हाट वन टू ऑल ब्रॉडकास्ट इज? One processor called the source or root sends the same message to all the processes in the network. I hope you are getting. After communication, every processor receives the same message. This is what one-to-all broadcast does. Important features देखते हैं. Same message is distributed to all the processes commonly used in distributed systems and used in matrix multiplication and distributed databases, or efficient algorithms are required to reduce communication time. नेक्स्ट आते हैं रिकर्सिव डबलिंग कंसेप्ट पे इन वन टू ऑल ब्रॉडकास्ट. इन हाइपरक्यूब टोपोलॉजी, broadcast is performed using recursive doubling. At every step, number of processes having the message doubles. Example with 8 processors. Suppose हमारे पास 8 processors हैं. Step 1, process 0 sends message to processor 1. स्टार्टिंग में रूट में 0 था, इसने मैसेज भेजा 1 को. Now processors having data are 0 and 1. Your step 1 has been completed. Next step, processors 0 and 1 send data to 2 and 3. 0 and 1 send to 2 and 3. Processors having data will be doubled. 0 1 2 3 हो जाएगा. Your step 2 is completed. Moving on to processors 0 1 2 3 send data to 4 5 6 7. यहाँ पर वापस से डबल हो गया. 0 1 2 and 3 send the data to 4 5 and 6. And 7. Now all the processors have the same data. और ये कहाँ से स्टार्ट हुआ? Starting from 0 and ending on 7. ये है आपका रिकर्सिव डबलिंग कंसेप्ट. इसका की फॉर्मूला है log of p, where p stands for number of processors. And what are its advantages? Fast communication, efficient data distribution, and reduces repeated transmissions. Moving on to all-to-one reduction. All-to-one reduction ब्रॉडकास्ट का बिल्कुल अपोजिट है. इट इज द रिवर्स ऑफ ब्रॉडकास्ट. हाउ सो? Every processor sends data towards one destination process or where values are combined using operations like sum, max, minimum, product. What is this? In this operation, every processor contributes data and data is combined at one destination processor. For example, हमारे पास एक array है or a list of numbers 2, 3, 4 and 5. हम इसको रिड्यूस करते हैं टू सिंगल नंबर बाय व्हाट ऑपरेशन? एडिशन. 2 plus 3 plus 4 plus 5. On adding, we get 14. सो चारों नंबर को रिड्यूस कर दिया हमने एक सिंगल यूनिट में. दिस इज व्हाट ऑल टू वन रिडक्शन डज. रियल लाइफ एग्जांपल से समझे तो सपोज एवरी स्टूडेंट सबमिट्स मार्क्स टू द क्लास रिप्रेजेंटेटिव. सारे बच्चों ने अपने सीआर को मार्क्स सबमिट कर दिए. अभी द क्लास रिप्रेजेंटेटिव कैलकुलेट द टोटल मार्क्स, maximum marks and average marks. So what it signifies, student students are the processors, the representative is the destination, and calculation is the reduction operation. In one to all, जहाँ पे एक रूट से डिफरेंट प्रोसेसर्स को इंफॉर्मेशन पास हो रही थी, यहाँ पर सारे इंफॉर्मेशन फ्रॉम ऑल द प्रोसेसेस आर गिवन बैक टू इट्स रूट सोर्स, जस्ट द अपोजिट. आई होप यू आर गेटिंग. दिस इज द सेम एग्जांपल which was given above. वैल्यूज चेंज हो गए. Important points to remember: reverse operation of broadcast is what all-to-one reduction does. Data moves towards one processor, frequently used in scientific computations. Next, we have all-to-all broadcast. Now, what all-to-all broadcast does is every processor is both sender and receiver, और इसके end of the process में each node contains all the messages from all processors. Suppose this is the sender A and this is the receiver B. Information पास हुई 1, same information C और D को भी पास होगी, and so on. Every processor sends its messages to all other processors. After completion, each processor contains all the messages. Example, real in real life analogy, imagine a WhatsApp group where every student shares their notes. एक स्टूडेंट ने अपने नोट्स एक व्हाट्सएप ग्रुप को शेयर कर दिया containing multiple students. So एक ही piece of information got transferred to all the students. All the students. What are its cons? This operation is more difficult because multiple communications happen simultaneously. Multiple communications happen simultaneously. There is too much network congestion and efficient routing becomes important. Also, this is a mesh based communication जहाँ पर it is divided into two phases. First is the row communication, second is the column communication. Best example is a matrix. If we take a 2 by 2 matrix, 1, 2, 3, 4, the matrix A will communicate with matrix B 1, 2, 3, 4, or we can take 5, 6, 7, 8, 5, 7, 8. What communication? Row wise communication. Row wise communication and then column wise communication. This is what mesh communication represents. After all the phases, the processors receive all the messages. इसके applications क्या है? In parallel databases, distributed machine learning, matrix operations, and HPC simulations. Next, we have the scatter operation. Scatter operation is basically जहां पर वन रूट प्रोसेसर कंटेन्स मल्टीपल डिफरेंट मैसेजेस। तो एक रूट प्रोसेसर हैज डिफरेंट पीसेस ऑफ डेटा और वो डिस्ट्रीब्यूट करता है यूनिक पार्ट्स टू ऑल डिफरेंट प्रोसेसर्स। सपोज एक इंफॉर्मेशन को मैंने डिवाइड कर दिया टू डिफरेंट पार्ट्स एंड डिस्ट्रीब्यूट इट टू डिफरेंट प्रोसेसर्स। एक ग्राफ से समझते हैं। स्कैटर, दिस इज अ स्कैटर्ड ग्राफ। Your information is unique and spread all over the graph. This is what scatter operation does. Example, teacher distributes different assignments to different students. Student 1 को टीचर ने दिया असाइनमेंट ए, स्टूडेंट 2 को दिया असाइनमेंट बी, स्टूडेंट 3 को दिया असाइनमेंट सी। Compared to broadcast, same message is not sent. If difference is asked between scatter and broadcast, its major difference is scatter operation contains different or unique messages. Unique. Unique is the keyword. Unique messages sent होते हैं and in broadcast same message is sent. Important features: personalized communication. Root processor distributes unique data as seen above and common in parallel data distribution. Its real life applications are parallel sorting, distributed file processing and big data partitioning. Next, gather operation. Gather operation is the exact opposite of scatter operation. Gather operation में every processor sends unique data back to the root processor, जहां पर scatter को divide करके different processors को भेजते हैं। वहां पे gather operation different processors के information को is directed back to its root processor. This is gather operation and this is scatter operation. For example, student submits different assignments back to the teacher and teacher collects all the assignments at one place. इसके important features है data collection operation, reverse of scatter and message size increases towards the roots. Major differences: one to many from root to different processes and gather में many to one from different processors to the root. Root distributes the data, whereas in gather operation root processor collects the data. In scatter operation message size decreases because from one to many it has been distributed. Compared to gather operation, the message size increases because from one processor it has been sent to the root processor. Next we have prefix sum operation. What prefix sum operation is? Prefix sum computes the cumulative sum. For example, step 1, there is node 0 containing 1. We iterate to 2 with node 1 जहां पर हम previous node को और existing node को ऐड करेंगे। तो 1 plus 2 gives you 3. Then हमको node 1 का आंसर मिल गया। Then we come to node 2. Node 2 is the summation of the previous three nodes 0, 1, 2, which is 1 plus 2 plus 3, 6. Node 2 का आंसर is 6. Node 3. Node 3 is the summation of previous three nodes 0, 1 and 2. For example, 1 plus 2 plus 3 plus 4 is 10. And your cumulative answer for prefix sum operation is this. रियल लाइफ एग्जांपल से समझते हैं. डे 1 के सेविंग्स हमारे 100 है. अगले दिन हमने 50 रुपीज़ और सेव किए. सो एट द एंड ऑफ डे 2 वी हैव 150 रुपीज़, 150 rupees, and at day 3 we save 200 rupees. On saving 200 rupees we add it to the previous saved amount which is 150 और हमारा सम होता है rupees 350. This is what prefix sum does. इसके एप्लीकेशंस है पैरेलल एल्गोरिथम्स, जीपीयू कंप्यूटेशंस, डेटा एनालिटिक्स एंड इमेज प्रोसेसिंग.